Okay, which one do you want to do? So let's say we go up to maybe it's about 7, right? I can go up to 8 o'clock, let's say, for now. So it really depends on which one you want to do. Okay, sure. Just give me tell me the question. I didn't. Okay, why don't I have a quick look? Okay, we can start with which one? Number 12? Okay, reverse off. That's the one, okay? Okay, how about we start with that? Reverse off, okay? So I think let's think about the idea first. Let me again connect my iPad. Once you see how the ideas work, it's not difficult. And we'll do that in Java. There are many ways you can do this one here. So let me show you the one you will know for now. Let me make sure my iPad is connected. No, that's not the one. Sorry, bear with me. Okay, let's do the. Okay, so now let's do the reverse. How do you do a reverse of the array? Okay, so let me just double check with the question itself. So you can see, in some way, we're going to take some sequence there and the return its reverse, right? That's the what we're going to do. Okay, let's just see some example on the notes and see how we can do that. Okay. Okay, so now let's see this. Okay, guys, please. Right. Okay, let's see how we do the reverse. Let's say I have an array that looks like this. Okay. Let's take A, B, C, D, and E. So indices should be 0, 1, 2, 3, and 4. So what I really want to return is just another array of the same size. Okay, so size shouldn't change. Also 0, 1, 2, 3, and 4, the same. We know that it should be E, D, C, B, and A. Okay? So now, let me just call this the input array. And this is the output. So output is the reverse of the input. Okay? So now let's see kind of the correspondence. You can see somehow the input at position 0 is exactly equal to the output at position 4. Agree? Right? A here matches A here. Similarly, you also get input at position 1 is equal to equals output at position 3, right? 1, which is B, and also position 3, also B. Okay. Similarly, 0, 1, 2, and 3, you can see 4, 3, 2, and 1. That's kind of the correspondence, right? Now, how do we automate this somehow using a loop? We want to generalize this. In this example here, the size of the array is input length is simply equal to 5. We want to see what's really the relationship between the size of the array and somehow how the indices correspond to each other. Okay, so let me just put this to be complete so you can see a little bit more clearly. Otherwise, they'll be confusing. We got input here, and then we also got input here. And we have output here, and we have output here. Okay, so now let's try to observe what's going on here. So now I want you to first of all to see, can you see any relationship between the indices in the input array and the output array? For input array 0, 1, 2, 3. For output is 4, 3, 2, 1. So somehow we say this index in the input array is equal to this index in the output array. Okay. Similarly, here is similar to equal to this, right? If you see the sum of the indices, it's one way to look at that. 0 plus 4, 4. 1 plus 3, also 4. 2 plus 2, also 4. 3 plus 1, also 4. Agree? So somehow, let me just call this, imagine that, since here we got 0, 1, 2, 3 on the left-hand side, you can think about we're going to have some loop counter called I. So let me call this I. We're going to use a different color here. So we have I over here, and somehow we're going to assign some index into the output array, somehow. Okay? So now we know that always I plus the question mark is exactly equal to the length of the array plus minus 1, right? So that's going to be the length of the array minus 1. In this case, it's 5. 5 minus 1, which is 4. You got 0 plus 4, which is 4. 1 plus 3, which is also 4, right? That's kind of relation. So now you can see that the question mark should be the length of the array minus I minus 1. So this is kind of what you need. Once you can be convinced this is the case, you can write things very easily. Any question about this before I move on? That's really the critical insight. So I think since we allowed you to bring some paper to the lab test, so whenever you're not too sure how things will work, draw some example on the paper that will help you, like what I'm doing now. Okay? So this is what I'm going to do. I'm going to run a loop, and then the loop is going to be from loop counter I, starting from 0, 1, 2, and 3. Every time, based on the current value of I would know what the corresponding position it is in the output array that I should assign. Okay? So that's kind of the idea. Okay, why don't we do that now? Length minus I minus 1. Okay? So now let me go back to Eclipse over here, and then let me just create the class. Let's call that my utilities. Okay, let's say public integer static. And then reverse of, and then we're going to have some array. Integer array. Let me just be consistent with what I have in the problem sheet. So that one there, I have just sequence. Okay. So now, first of all, you got to, so this is some syntax you're supposed to know, how you can create a new array. So I'm going to have an integer array, and then I can just call it output. Okay, it's assigned to a new array, integer here, and what should be the length of the array? We know that input and output should be the same, right? I can say sequence dot length. Eventually, I'm going to return output, eventually. But there's got to be something that has to be done in the middle. So far, so good? Okay, now let's do the magic here. For integer I is assigned to 0, I less than sequence.length, I plus plus. Now I'm going to say output at, I'll say question mark here. So this question mark is what we said before, it's a question mark, right? It's assigned to input at position I. And as we figure out in the previous iPad note over there, you can see that, let me just show you very quickly. The question mark there is really over here. Length minus I minus 1. Okay, that's how we figure that out. So now let me go back there, and I can say sequence.length minus I minus 1. Okay, sequence, not input. Okay, that should be it. So now, question for you. Now, what I said there was, I said the precondition, here the precondition is that the array is not null, right? We can easily do that. Let me just show you for this example here. You can say if the sequence is equal to null, which means no array to do. So you're going to throw new illegal argument exception. And then I'm going to put it inside here. Now, a question for you. What if the sequence array is actually empty? What's going to happen? Which means sequence.length will be 0, right? In that case, in this line over here, we're going to create an empty array, right? And then, as you can see, I is initialized to be 0. Sequence.length is actually 0. 0 less than 0 is false, which means we'll never go into this loop when the array is actually empty. So we'll just return the empty array directly, which makes sense. The reverse of an empty array is still empty array. Okay? And similarly for other non-empty array. So now let's do some tests very quickly. Okay? And you can now do new JUnit test. I just try to test a few cases. So test my utility. Okay, let's try to say test reverse. First of all, let's start with integer empty array. New integer, just that. That's a valid case. Just empty, just size 0. If I say, I want to make sure my utilities dot reverse off. Okay, empty array. It should still be an empty array, right? So now, let me just do something here. Integer expected. What we expected to happen, just another empty array. Like that. So now, I will just say, what's actually produced by my program is this array, right? So now I want to make sure expected matches actual, right? So now what I can say is assert equals, assert, there's some method there which is called assert array equals that you can also use. So I'm going to put some array here so I can say expected and then actual. Okay? So now if I run the test, passes. Okay? Let's try one more. Let me now change the array to be something a little bit different. Let's say integer. Let's say A1 is, let's say 1, 2, and 3, like that. Okay? And now, what I expect to really happen is going to be 3, 2, and 1. And what's actually produced, oh, let me just reassign expected. That's fine, because it's already declared. What I actually defined was my utilities dot reverse off, and then I can just put A1 inside. And then, now I can assert again. Okay. There's something we got to do here. Somehow in Java, once you already initialize an array, you cannot reassign that to this notation here. Maybe you have realized that from the previous course, but it's easy to compensate. So we can simply say integer expected 2. Expected 2, right? Okay, just some trick over there. Why don't we have a look? Okay, now it's correct. You see, the way I do this, I didn't really code right away. If you're very confident, of course, you can go ahead and do it. But if somehow this problem is new to you, what you should really do is see some examples first, and then to look at how the indices correspond to each other. Okay, that's usually how you solve new problems. Make sense to you? Okay, so that's about the last one. Okay, next. Yeah, let me just say a few more things. So I think actually this exercise here illustrates quite a bit array syntax you should really know when you come to the lab test on Thursday. First of all, you should really know how to do precondition violation over here. And also you should know how to create a new array of certain size. And you can give it an array, you can know the length by using .length. And also you should know that the index should always start with 0, go up to maybe length minus 1, right? Okay, yes. Which one? Number 8. Yeah? I will post it, don't worry. Yeah, I'll post it. So I would say, don't worry if you don't have to catch up with me typing, that's fine. Yeah, you just want to understand. I'll post everything, don't worry. Yeah, no secret here. Okay, well, if I really want to give out some solution to you guys, I will turn off the recording, don't worry. No, I'm not going to do that. Okay, number 8, right? Number 8, okay, that's interesting. You're given a sequence over here. You want to determine if there's a Fibonacci sequence. Okay, let me give you some idea over here on the iPad again. Okay, so this is our this is definition for a Fibonacci sequence. If I do give you this one on the lab test, I will tell you exactly what Fibonacci sequence is. So now the shortest one you can get is just 1 and 1. That's the shortest one. If you got longer one, you're going to be 1 and 1, and the third element, starting from the third one, the value of that is going to be the sum of the previous 2 elements. In this case, that'll be 2. And the next longer one will be 1, 1, 2, and then 3, right? But you pretty much know what the Fibonacci sequence is. Okay? So it's got to be, the length must be at least 2. Okay? So you can see that back in the question there, the precondition for this method here is the sequence is not null, and also it contains at least 2 elements. Let's figure out how to write this precondition first, and then we'll go on to decide. Okay? So now let's go to my utility here. Okay, let me just maximize that. So now public static Boolean is Fibonacci sequence over here, integer, and then sequence. We know that, first of all, the precondition means it must be not null, and also it must be the case that it must, there should be at least 2 elements there. So which means if either it's null, sequence is null, if this is the case, or there will be 2 ways you can fail this, either because it's null, or it is not null but it has less than 2 elements, or sequence.length, okay, is actually less than 2. Okay, in that case you say throw new illegal argument exception. So far so good? Okay, so I think be very careful, because usually when I mention about the preconditions, I might just say that in natural language, so you got to be watched very carefully. Okay. Okay, now how do we decide? So now at this point, first of all, let's document the code just for the purpose of clarity. So now reaching this point, we know sequence has at least 2 elements, at least. Okay? So now to be a Fibonacci sequence there, we know that it's fixed. The first element must be 1. The second element must be 1 as well. Once we figure out these 2, we can go and then build some loop to decide the rest. Okay? Let me just show you the idea, and then we'll come back to write it. Again, let's see this. Let's say if I give you a sequence like this, let's say if this is the input, if this is the sequence you're given, let's say you're given 1, 1, 2, 3, 5, 8. Let's say that's your input. This is how I'm going to decide. First of all, I know that it has at least 2 elements. I don't necessarily have to run a loop right away. First of all, I'm going to check the first one must be 1. The second element must be 1 as well. First of all, I got to pass these 2 checks first. If the first 2 elements are not simply just 1, there's no way it can be Fibonacci sequence, right? And then starting from the third one, I'm going to run a loop to say every time I'm going to run a loop counter starting from 2, right? And then every time when I'm here, I can always look at the previous 2 elements and see if the sum will be equal to that. Now, be careful. A very interesting case that looks like a Fibonacci sequence, but it's not. What if I give you something like this? 2, 2, 4, 6, 10. You see over here, starting from the third element over here, 4 is equal to 2 plus 2. 6 is equal to 4 plus 2. 10 is equal to 6 plus 4. So far, so good. However, you see, just the beginning 2 elements do not pass the check. So that's why it should not be. That's why I got to do the beginning checks and later checks. Okay? So both checks are important. We're going to test. Having that in mind, let's try. So I'm going to do this in the most efficient way possible, but you can feel free to adapt that. Boolean is Fibonacci sequence is simply, I would say, yeah, that's fine, is Fibonacci sequence. So now I'm going to give it some value right away. I'm going to say, since it's guaranteed at this point is at least 2 elements, I can say sequence 0 equals 1 and sequence 1 equals 1. First of all, I'm going to check the first element must be 1. The second element must be 1 as well. If they are not, this will be false. Otherwise, it's true. And now I'm going to run a loop for integer. Since I already have taken care of indices 0 and 1, I can say int I is assigned to 2. I less than the sequence, the input length, I plus plus. And then I can say is Fibonacci sequence is equal to, is assigned to, I can say sequence at position I is equal to sequence of I minus 1, the previous one, and also even the previous one. However, this right now is actually wrong. There's a logical error over here. You can see over here, we are only to say every time when we are at a position I, we are checking to see if the previous elements, the sum, is equal to the current one, right? Try to say, what's the wrong? No, nothing about it. Let me, okay, for the sake of saving some time, I'm going to explain to you on the paper first, and then you can try to watch a recording and see if you're convinced. Okay? If I have the code like this, just for now, okay? I'm going to give you some example over here. Let me just give you another one. 1, 1, 0, 1, 1, 2. This is not Fibonacci sequence. Agree? Let's see how we do the check just for the code right now, which is wrong. This pass. So now I say I, which is 2, is equal to I minus 1, I minus 2. In this case, no, it's not the case, right? 0 is not equal to 1 plus 1. However, I didn't accumulate the result, right? Remember, if I go back to the code, I simply say I'm just going to see what the current value is. Now, let's say I go to the next iteration. If I go to the next one, now, is 1 equal to 0 plus 1? Wow, it is. So I'm going to override that false to true. So somehow that false has been wiped out. It's not being replaced by true. And now if I go to here, 1 is equal to 1 plus 0, yes. 2 is equal to 1 plus 1, yes. Right? So the last result I will get is simply true. So that's not accurate. Okay? So there are 2 ways to fix it. Yeah, Raymond.
One way to fix it.
Yes, why don't you suggest? Let me go back. Tell me how you can fix it. There are 2 ways you can fix it.
In the work, could you put and right there and then make sure that
Exactly. This is one way. And this is actually quite efficient, which means as soon as you find out if the current element is not equal to the previous 2, the sum, you're going to stop. And we're just going to make the state condition false. Another way to do it is, if you like, you can say, I'm going to accumulate the result. That's another way. So this means once the conjunction, once you have one side being false, it's never going to become true again. Right? So there are 2 ways you can fix it. But for this second version there, it's slightly less efficient. Let's say if the violation of the Fibonacci property occurs very early in the sequence, the first version you just suggested can let us exit right away. But this version here is going to go through the sequence no matter what. Right? Yes, question?
if you nested the for loop in a while loop with the condition being is for the sequence, would that also work?
You mean have a double nested loop?
And just nest like the for loop? Yeah, I guess so.
But you don't really need that in this case, actually. I think for this case, a single loop would be okay.
What is still worth
Maybe you have to show me your specific code. That'll be, yeah. Okay, so let's, so you got two fixes. You can watch a recording. I'm going to show you the one that Raymond suggested, which is more efficient, okay? Okay, now I want you to think about one more thing. Okay, so now think about if I give you a sequence with two elements only, 1 and 1, is it a Fibonacci sequence? Just 1 and 1. It should be, right? That's the shortest one. How is it going to run through this code? First of all, you can see the Boolean here is going to assign to be true, right? And then you can see that again, we got a similar trick here. The way we set it up. So now sequence.length is 2. I is initialized to be 2. 2 less than 2, false, which means you never get a chance to check any further. So that's correct. Okay? Are you okay? Or okay? So now, of course, finally, we're going to return that Boolean variable. Okay, that's it. Okay, why don't we go back to test? Let's test, okay? If it doesn't pass, Raymond, you'll be the person to blame. Since you suggested the fix, we'll see. Okay, public void test. So one of you asked me the question, should you know JUnit test? I think you should. Let's say you write something similar to this. Can you just trust that you will just write it and you will just pass all the tests? We're going to test you? No, you wouldn't, right? So you better test yourself. What I can tell you is I'm not going to give you any tests during the lab test. You're going to write it and test by yourself. Okay? That's something you really want to practice. Okay, test is Fibonacci sequence over here. So first of all, integer. So I will leave the precondition violation test to you. Just try and catch. I'll leave that to you. So let's try the simplest one. So let's say, I'll say sequence 1 is new integer. Let's just put this. Let's say 1 and 1. Okay. So now let me just do a little bit more efficiently. Assert true. My utilities dot is Fibonacci sequence here. I'll just say sequence 1. That one should be true. Good. We haven't reached Raymond's code yet. Not yet, right? It's a very simple case. Let me just double check. If I give something that's wrong, what about 2 and 2? If you try that, ooh, why is that? Is that true? Of course, thank you. You see, don't get yourself confused during the lab test, right? You did something right, but you thought it's wrong. Thank you. Thank you. Fantastic, very good. Okay, let's just do one more, okay? I'll do 2 more, actually. Integer sequence 3 is, let's do a valid one. 1, 1, 2, 3, 5, 8, and 13. This should be true. Good, thank you. Okay, so now let's do sequence 3. It is true. Great, fantastic. So now let's do one more. Let's say I start with 2, 2, 4, 6, 10, 16, 16, and then 26. So this should not be right because the starting point was not right. Okay, this should be false. Okay, good. All right, very good. Okay, next. I can do more, don't worry. We still have time. Any questions, or you want to move on to the next one? Rock, paper, scissors. Rock, paper, scissors, right? Question 1. Rock, paper, scissors. Okay, no problem. For this one here, I don't need to sketch any idea. Why don't we just do it right away? Okay. Okay, let me just copy the signature of the method here and see how we can do it. Okay, so now let me go back there and So we want to know which player actually will win. Okay, so basically we're just gonna compare, right, to see how we can do it. Okay, so now, so in some way you're going to enumerate all the possibilities, right, for player 1 and player 2. Think about this. For player 1, it can be either rock, paper, or Caesar. For player 2, also rock, paper, or Caesar, right? In that case, we got many possibilities there. So what I would say is, let's do this. If player 1 has got rock, yeah? Of course you can use case, but for me, I just used to use if then else. I'm not very familiar with the syntax, to be honest. How do you do case? I'm not too sure, actually. I don't really use case a lot. I just use if then else. Well, you can certainly do that. For me, I really didn't bother using switch and case too much myself. So I need to look up the syntax, but you don't want me wasting time doing that. So I think if then else will be sufficiently enough. You can easily translate that into the case. Okay, why don't we try that? Okay, if P1 is R, now how many possibilities do we have P2? 3. P2 can be either rock, else if P2 can be P, and otherwise we're gonna check some precondition. I'll show you, and otherwise it basically means P2 is Caesar. Okay. So now, in this case, let me just say return over here. If rock and rock, that means it's a tie, right? Let's say tie simply means, let me just say return 0. I didn't really say that in the question. Let's say 1 means player 1 wins. If 0 means nobody wins, just 0. Okay, rock versus paper, that means P2, right? Return 2. Otherwise, it's rock versus Caesar, so that'll be return 1. Okay? Let me just do some precondition check. If it is not the case, okay, let me just say this. If it is not the case that P1 equals rock, or P1 equals paper, or P1 equals Caesar, right? That's for the validity of P1. If either this or it is not the case, you see, it's a little bit tricky here to put the things together, right? P2 equals R. Basically, I can just copy and paste. So I think the tricky thing is you gotta know what the correct logical operator to use. Okay, I will explain to you in just a moment. Okay, in this case, we're going to say throw new illegal argument exception. Otherwise, we can go on. And of course, it's not done yet. I'll show you the rest. So now, in the else part, if we can reach this line, reaching this line means P1 is either R, P, or S. Same for P2, right? It's guaranteed. Otherwise, we would have thrown the illegal argument exception, right? It's guaranteed. So now let's have a look at here. So one way to see this is we are trying to say if either this is the case, which means P1 is not valid, or it is the case that P2 is not valid. In this case, we're going to throw the exception. So what does it really mean when P1 is not valid? Which means P1 is neither R, P, nor S. You learned about something called De Morgan, remember, in the logic. De Morgan means not brackets P or Q, equivalent to not P and not Q, right? Okay, now let's apply that. That's why the pity thing is your instructor don't usually tell you how useful logic can be. You only realize after you either fail the course or pass the course, right? That's a bit too late. Okay, anyway. logic is useful. Let's try to think about this. This is equivalent to, when we say P1 is not valid, that means P1 is not R, P1 is not P, and P1 is not S. It's something else, which is not allowed in this case, right? That's another way to look at that, okay? Okay, so now let's continue. So what we just did was if P1 happens to be R, so now we can simply say else if P1 is simply P, right? Paper versus rock. So that means P1 actually win. Paper versus paper, 0, tie. And then paper versus Caesar. So that means player 2 wins, right? Finally, we can simply say else because it's guaranteed. So this means P1 is Caesar. Okay, in that case, we can just go and copy this code again. Okay, now we got Caesar versus rock. So that means player 2. Caesar versus paper. So that means player 1. And that's a tie. You see, the idea here is not difficult, right? It's kind of simple idea, but to really code it up, that's a bit tricky. But that's how you do it. Should we try? Shorter solution? Wow, that's the most intuitive solution I can think of. Yeah, but sometimes you don't want the solution to be too short, right? If it's too short, there's no way you can keep track of, right? I think that's reasonable. If somehow you're aiming for some very shorter solution, you might miss some boundary cases. So I would say in the lab test, you want to aim for something that's intuitive to you. Don't worry about whether it's being too long or too short. Yeah. Should I leave the test cases to you, or you want to test something here? You know what? In some way, it wouldn't make sense if I tell you how many, right? If I say there's only one question there, it could be something that's incredibly hard, right? Or it could be 10 questions there, but every one of them is like a computed area of a circle, right? So it doesn't make sense if I tell you that. Yeah, you'd rather not asking, right? Go ahead. No, I will not. Yes, yes. So somehow I want you to somehow be responsible for your code. The question was, am I going to give you guys JUnit tests for your method? Let's say, for example, if I want you to implement the rock, paper, Caesar, am I at the same time going to give you the JUnit tests? The answer is no. I want you to code up the example there and then to really see how many tests you actually need, right?
So are you going to see our JUnit or just see Java?
Mainly the Java code, yes, yes. If I have a very explicit question to say, now, this question is, I want you to write a JUnit test for this particular thing. And in that case, I will judge, of course. Yeah. Mm-hmm. Guys, you want to do any more? But it's completely up to you. If you want to do more, I can do more. Yeah.
Will array list gonna be in the test?
Well, array list. I would say the bottom line is the additional exercises are all about arrays, the primitive arrays, right? In that case, you don't need any API. You already know how to deal with the primitive array, right? So now, if I give you any array list questions, I will give you the API. Yeah. Array list? I can do some very quick examples with you. Arrayed. You mean array list, right, from the Java library. Okay? So now, for example, what you can do is add test public void test array list. Basically, for using the array list, you can simply say, you got to declare some type for the array list, right? Let's say it's a string type, for example, right? I suppose you learned about array list maybe in 1022, right? So array list, let's say it's a list. New array list, just empty, okay? Initially empty. So now it's very easy. For example, you can say list.add. It's going to add to the end. Okay, I'm going to put Alan here. Okay, I'm going to put another one, basically add to the end. Alan, Mark, and Tom. Okay, so now, the primitive one, well, let's say we can try to do some assertion. You can say assert true. So list dot get some elements at position starting from 0. That should be equal to ln. Sorry. Okay, and then let's do, you can say get position 1, position 2. Mark and Tom. Okay? That's some, how you can add something or get something. Okay, right? Yeah, but I would say it certainly wouldn't hurt if you review some array list. But for this section, I think mainly it's the array you have to watch for. Yeah. Any questions?
Are we regulated whether the same function but it's more efficient or less?
No. For this test, no. As long as you produce the right output, then I'll be happy. Yeah. Just don't have any infinite loop.
No.
If you have infinite loop, it's not about being inefficient. It's just about killing all the processes in the server. Anything else? What do you mean the second one? Oh, second problem. Okay, you got something related to this? Oh, okay. Okay, second problem, right? Let me just review what the second problem is quickly. The second one is, the second maximum. Okay, let's try that. So there are different ways you can do this, right? So, of course, I will call the cheating way is you can simply create an array of size 3. Assign A, B, and C into the array. You can call arrays, there's a class called array that sort, and then find out the second one. If I do give you this question, I might say something like, you are not allowed to use arrays in this case. I'm thinking about that, right? If I do give something like this, I would say that, right? Let's say we don't have that option there. Then let's see how we can do it, okay? But it's only 3 elements, right? Let's see how we can do that. I tell you what the idea is very simple, okay? I tell you what the idea is. You can feel free to simplify that, but I think this is the most intuitive way to do it. Okay, it's easy. So let's say we got add a page below. The idea here is, okay, so we got 3 integers, A, B, and C. In terms of arranging their orders, how many possible ways can you arrange them? How many ways? Girls, how many ways? The question is, we got A, B, and C being integers. Let's say they are just unique. There's no duplicate to make it easy. How many ways are there possible for you to arrange the order of A, B, and C? How many? I heard 3. 6? How did you figure? Well, let's say, if I give you 4, then how many would there be? Well, it's a 3 factorial, right? Right? Well, let's say if I give you n integers, how many ways can you arrange them? N factorial, right? Here it would be 3. Okay, it's 3 factorial. Okay, the idea is very simple here. So 3 factorial way of arranging the order. Let's enumerate them out. Very easy. No, don't worry about it. It's very easy. If A is the first one, it can be B, C, or C, B. B is the first one, it can either be A, C, or C, A. If C is the first one, it can be either A, B, or B, A. So 6, right? So the most naive solution, but we will be very quick. Once you do one if branch done, you can just copy and paste. Okay? So you can see in all the cases, sorry, just switch that to the wrong thing. These are the second element you're looking for, right? Okay? You can feel free to simplify this if you like, but I'll leave that to you. But if I were to take the lab test, I would choose the simplest one that can have things going. Okay? But any question about this intuition here? We're okay, right? Okay. This is how I'm going to code it up. Let me go there. Let me go there and then go to, let me just copy the signature. Okay, let me go there. I'll leave the test to you, but I will just code it up first. Okay, so now I would say integer result initially just -1. Okay, eventually I'm going to return result. Second maximum. So now I'm going to say, first of all, ABC. If A less than or equal to B and B less than or equal to C. In this case, B is the result. As I promised, you can just copy and paste. Temporarily, I'm going to say else if. Okay, copy. So we got 6 cases, right? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? ABC and ACB, right? I'm sure you can do much faster in a lab test than I am, but anyway. So, and then we got B. Starting with B, it can be AC or CA. And we have B here, C. Let me know if I've got any mistake. Now we can start with C. It can be either AB or BA. Of course, if you're too nervous, don't write anything like this. When you say, if C less than equal to B less than equal to A. You know that it wouldn't compile, right? That's why I'm writing the conjunction. Okay. Now, let's fix this. In this case, the maximum will be B, C, A, C, A, B. Makes sense, right? Good. I'll leave the test to you. Well, if you can think about some one-line simplification, let me know. I would like to know. Okay. Okay, next one. We still have time. Any questions? Yeah, we still have about 5 minutes or 10. Should I take side? Yeah, yeah, go ahead. Oh, in the array version. Sure, no problem, no problem. Yeah, you're talking about, yeah, I see what you mean. Let me just review that signature there, yeah. Let's say over there, yeah, I see what you mean. Let's not worry about the precondition for now. I will let you complete that, okay? Let me just go back there. Let me show you, it's very easy. Okay, it's still gonna, let's say integer result is -1. Okay, and then we're gonna have return. Okay, can I cheat just a little bit? I want to keep A, B, and C. I'm gonna say array. Doesn't matter, right? The name of the parameter. Now, I can simply just basically copy and paste this one. I'm gonna just, yeah. What should I do? Well, now it's complaining that A, B, and C are unknown. Why don't I just assign A, B, and C? Integer A is array at position 0. Integer B is assigned to array at position 1. The integer C is assigned to array at position 2. Done. Okay. Oh, guys, does it make sense to you? Okay, basically, the question was, now I just changed the shape of the input. It's now, rather than 3 discrete integers, it's now just an array. So I just need to figure out what A, B, and C are. Okay? So that was the question. Yeah?
Is there a way to do it in the source?
Well, of course there's a way. As I said before, I believe what you can do is, but you know what? I would say don't really rely on that solution, because I might simply say in the lab test, no, you cannot use array. I'll explicitly say that, right? Let's try that anyway, okay? For example, let me use this. Let me use that one there. I kind of actually even forget how you do that. Okay, we got this array here. Array. Oh, isn't that great? And then I believe you can just return array at position 1. 2-line solution. I
Is that understood the question? There is no array size.
Sorry, say that again.
Is that understood? It's a given array of numbers, so there is no array size.
You mean, yes, okay, let me just refer to the question, yeah. So which question are you talking about? Number 3, okay. Given, oh yeah, array, yeah, exactly, you don't know the size. Oh, right, you're right. Oh, thank you so much. Very good. So that's exactly it. Right. So guys, sorry about that. I got myself confused. So now, the version I just did, okay, let me just say what we have done. Yeah, I'll get to that. Thank you. Yeah, I'll do that one as well. So the one we started with was A, B, and C. We think about all the possibilities over there, right, to see what the second maximum is. And then we do another version there where we assume only 3, let's say assume array.length is equals to 3. That's the assumption. However, that's not really question 3 was asking. It's not, okay? Very good. And back to your suggestion there, we're using array. That's also work, but I might say you cannot do it, right? Okay, so now let's go back to the very original question, okay? Max 2, I would say that's a simple version, okay? Let's go to the very initial one. That one is actually not too bad, okay? I'm gonna do that here. Maybe that will be our last one, maybe for today? Okay, very good. Let me now do that in full detail, okay? So now over there we have over there. And the precondition is A is not null and contains at least 2 elements, at least 2. Okay, so if A is equal to null or A the length is less than 2. In that case, we don't really have the second maximum, right? Good. So now we're gonna throw new illegal argument exception. Otherwise, we're going to do it. Okay? Okay, let's see how we can do it. So now the idea is, think about how would you, let's say if at the question I changed to be much simpler one, figure out the maximum in the array. How would you do it? You'll simply start with some initial maximum there. You just keep reiterating through the array and then update it when you need to. Now just change that a little bit. Now I'm going to maintain 2 integers there. First maximum, second maximum. I need to update it when necessary. But the update process will be a little bit more complicated. Okay, that's kind of big idea. Okay, how about I show you one example quickly. Okay, let's say over here, let's say we got an array. Let's say 2, 3, 1, 5, and 6, for example. So at least 2 elements. Let's say I would say maximum and second maximum. Okay, I'm going to take the first 2 elements in the array and decide which one should be the maximum and second maximum to begin with. In this case, it will be 3 and 2. And now I can see 1 over here. 1 is less than the second maximum, so I don't need to update them. 5 is larger than the maximum over there. So I need to kind of push them away, right? So this should be 3 and 5 somehow. What used to be the maximum is now the second maximum, and 5 has now become a new maximum. And similarly for 6, again, 6 should now be the new maximum, and what used to be the current maximum should be the second maximum. So now we got 6 and 5. Okay, that's kind of the idea. Okay, you can review the example in the recording. Let me just code it out very quickly. So I think somehow once you run through some example and get an intuition, it's much easier for you to code it up. Okay, let's see this. So I'm going to say max is assigned, I'll just say -1 for now. Integer maximum 2 is -1 for now. Eventually, we're going to return maximum 2, eventually. Okay, so now, if array A at position 0 is less than or equal to A1, in this case, we know that maximum should be A1, and maximum 2 should be A0. Otherwise, it is the case that A0 is greater than A1, right? In that case, maximum should be A0. And maximum 2 is A1. So far, so good? Just the very first two. Okay? Now we're going to run a loop. For integer I is assigned to 2, starting from 2, I less than A dot length I plus plus. Like that. So now, how do we update? Basically, let me just draw a little bit more conceptual picture to you. Okay? And then we're almost done. I'll leave the test to you. Let's say conceptually, if this is max and this is max 2. Okay? Now we have a new number to look at. If the number happens to be below maximum 2, nothing to worry. If the number is somewhere between max and maximum 2, in that case, this number should become the maximum 2, the new one, and max remains the max. Otherwise, the third possibility is maybe the new number is above the max, in which case that new number becomes a new max. And what used to be the max is now become the second max. We got 3 possibilities there, right? Only 3. Okay? Okay, let's code it up quickly. So now if, let me just, integer current is A at position I. If current is simply less than maximum 2, nothing to worry. I'll just make it explicit. Else if current is in between, let's say it's in between maximum, is greater than maximum 2 and maximum, let's say current is less than or equal to, right? So you know what? Let me put it this way. Maximum 2, the current one, is less than current, and current is less than or equal to the max, right? In that case, we're going to replace one of them, right? So that means maximum 2 is assigned to current. Okay? Else if, so this one you can think a little bit more, since I'm going to make the code available to you in the recording. If the current is simply larger than or equal to maximum, that means we're going to change, right? So that means the current, the max is equal to current, and max 2 is equal to max. Yeah, think about the concept I just talked about, and then I hope that will make sense. This one is a little bit tricky, right? But somehow I kind of know the answer already, so I can tell you in a faster way. But you should really definitely think about it and try to do it yourself. Of course, what you really don't want to do by Thursday is to memorize the solution, right? I'm pretty sure you'll get nervous on Thursday. It might be even worse. You might just memorize the wrong answer, right? So don't memorize. Questions before I let you go? I think it would, yeah, of course, it would definitely help. I can tell you that somebody asked me about how many questions I might have, right? So I can answer that. I think that person is gone. Okay, anyway. So I'm thinking about to give you roughly between 3 or 4 methods to implement. 3 or 4, roughly 3 or 4. And then there might be some written questions, which might like a short answer. So 3 or 4 methods to code up, and some methods to write up, some answer to write down. Sorry, say that again? You mean the methods? I would say no, just utility methods. Yeah. Okay, guys, good luck on Thursday. All right, no problem. See you later.